This talk will be done by Camilo Cardona. It's about prototyping interactive dashboards with Jupyter networks. So Camilo, when you want, you can start.
Okay, thank you. So I'm Camilo. I work for Cisco Systems, but most of the content that I'm going to explain today, I also, let's say, learned it from my previous job as a PhD student in an institute in Madrid called India Networks. So I also should thank them. And it's about doing interactive dashboards in Jupyter. That is, putting buttons and stuff so that you can play with them and see changes. Okay, so most of you might have a reason why you want to have interactivity in your Jupyter. You might have a reason. I will argue that even in the most fancy projects, you might also need this kind of tool. So let me try to set like a problem statement. So let us say that we are in a project, really nice project, and we're in charge of the process or analysis of data. These fancy projects usually, well, sometimes the output, they have to, so the end users are non-coders and they have to interact with our project somehow. So, or with the process that we're making. Maybe you need the end user to modify some parameter of the process that you're doing, of the analysis. They need to trigger some operation or, well, stuff like this. So how can we offer a non-coder user interactivity with our process? Well, there are these very fancy web frameworks on JavaScript that, thanks God now we have that, because 10 years ago everything was Java and it was a pain. But now we have that. They work very well, and they're scalable if well done. But I don't know if you have the experience on this, because to be well done, they actually have to be tuned and tailored exactly for the project that we're in. And that means that usually they are not going to be done only until later stages of the project. So that's basically mostly at the end part of the project. However, if we're going to have this kind of system, we need to have a way in the early stages of the project to have a prototype, let's say. So for many reasons. For validation, let's say that probably the end users are experts on the field more than us, and so we want to see their feedback on what we're doing so that we're doing correctly. Maybe they want new features, stuff like this. So prototyping, having a prototype of the UI is good. However, I mean, I don't know if you have played with these JavaScript UIs. I find them really painful, and it's really hard to hook our Python pipeline with them. I mean, you might have some way of doing it. I don't. It's kind of hard. So the problem that I have, and I try to more or less give you a way of doing it, the question that I have is, how can we build a prototype of a UI without leaving Jupyter? There are other reasons why you might need an interactive dashboard because of a proof of concept or stuff like that, but there are many reasons. But this is one that I like and I suffer, let's say. So I'm going to give you a proposal. It's using, well, Jupyter. Well, the Jupyter notebooks. I'm going to use a library called IP widgets. It comes from also from the same group of Jupyter, plus another widget which is called Jupyter Matplotlib, but basically allows me to put figures in the widgets. Plus another extension of Jupyter called Jupyter Dashboards that I will explain later, but basically lets you put the cell outputs in different layouts on the screen. This is a proposal. So bokeh dashboards is also another alternative. I think for prototypes, both of them were well. I just work with the first. But if you're feeling better with bokeh, that's also okay. Okay, but let me just give you this introduction of these IPy widgets. So basically, IPy widgets they offer Jupyter ways of appending HTML widgets in your Jupyter notebooks. So the basic ones that you probably know. So buttons, text fields, HTMLs, boxes, stuff like this. So, well, unfortunately, you cannot see it very well, but let's say here, besides importing the libraries, there's nothing more you have to do. You just create buttons, you create text, and then they appear on the screen. They were like this. Nothing fancy so far. Okay, what else they offer? To me, the killer application of a widget library are the layout widgets. Layout widgets are basically widgets that allow you to arrange other widgets on the screen. The IPy widgets have 3 of them. They're boxes, vertical and horizontal, tabs, and accordion. We're just going to play with the first 2 here. The key here, or the beauty of this, is that Layout widgets can have other layout widgets as children. And so you can basically do any, let's say, fancy layout that you want, as long as it's squares. Don't never think about spheres, but as long as you want a square type of layouts, you can do it with this type of hierarchy. I have here an example. So before this cell, I created a couple of buttons, a couple of text. In the first line, I'm creating a vertical box, and I'm putting one button and one text there. In the third line, I'm creating a horizontal box with another button and text, and I'm using a layout object of the same library to basically extend it so it has a bigger width. And then I'm creating a tab here, a tab object, and I'm placing the two other boxes there. So, well, I mean, simple. I mean, here the box with here's the tab with the vertical box, and here's the box with the tab with the horizontal box. I don't know if you already see it, but using this type of things, you can basically get any layout that you want, and it's simple. So the complicated part comes in the business intelligence of what you want your things to do. That nothing can solve you. That is on your own. Obviously, the library offers some callbacks for the widget, so you can actually do stuff with them. I basically use two callbacks. For buttons, I use the click button. And there's like the generic callback called observe that basically allows you to register which function you want to be called when specific traits of the widgets are changed. So when the user changes something, then the function that you register is called. The traits of the widgets may differ, but here what I did, for instance, was so I created a couple of functions. This one, for instance, changes the text. And this disabled text, every time that I change the text on the text box, the text box gets disabled. I mean, nothing super fancy, but you see, with this, you have the building blocks to basically doing most of the basic stuff. Okay, so the IPy widget actually doesn't come with a widget that allows you to have figures. And I don't know, well, we're in PyData, we know that we have to plot figures all the time. There's this library called, well, there's this, let's say, that widget is separate from the IPy widgets. It's called Jupyter Matplotlib. Well, this is a link. By the way, the presentation is on GitHub if you want to download it. When you import this library, and it's made by people active on the Jupyter project, then you can basically have Matplotlib figures within the widgets. Because what I want is for them to play nicely with the layout widgets, because that's how I make my prototypes. So how it works is Matplotlib, when you have a figure, you have figure and axes, right? Axes are like the children of the figures. But the figures actually have like a parent, which is a canvas. And the canvas depends on the backend of the Matplotlib that you selected. I mean, it depends how imported. So what this Jupyter Matplotlib library does is it makes the canvas be a widget. So that's how it plays nicely. There's another library called BQplot. Actually, it's made from the same guys of Jupyter Matplotlib, I think. Thanks to them on the distance. They don't know me, but thanks. That one is another alternative, but I don't know how it works. So I'm just going to go with this one here. Okay, so just an example. So here I'm creating a figure, first line. I'm setting it on size. And then I'm creating a couple of buttons that clean the figure or draw something silly on it. And what I want to show you actually is that the good part is that the canvas becomes kind of a widget, so I can put it within a layout widget, in this case, a silly HBox. And if I wanted, I could put that box into a tab, and I could put that tab into another tab, and stuff like this. So this is the beauty of these widgets. Okay, the other element that I told you is Jupyter dashboards. There's nothing really fancy about it. So basically, we're going to come to this at the end, but basically what it lets you is that it lets you, so the output of this, for instance, of this notebook, I mean, this is a log notebook, well, long, and what the dashboard allows you is basically to be able to place the output of the cells in a specific grids. So you can move the sizes, and you can place the outputs in different layouts. Nothing really fancy, but it really works well for a prototype if you want to get your message conveyed. And that's it. I mean, there's nothing more about it. So, but it's powerful, I believe. Okay, so why it worked for me, or why it's working on my job, basically. This is far from idea from product. I mean, if you come to me and you tell me I'm going to create a product based on this, I'm going to tell you, well, okay, you're a bit crazy, because it's not really super duper perfect. But for prototypes, works great. It's relatively simple. It offers what you need. I mean, text you can show with the text boxes, with the HTML, graphs with the matplotlib that I show you, and tables. Pandas now, the data frames have this style option. I think it came out a couple of versions ago, and it lets you have the output in HTML. It's very flexible, and together with the HTML widget, you can basically have your tables look nice, actually. We still need a better data frame widget, I say, so that we have more interactivity with the tables. I think the bokeh dashboard actually has one that is a bit better, but I haven't played with it, but in case you want to check it out. And it worked for me, and I've been telling you that because of the Lego approach. So the point is this, is that many of these widgets, so the layout widgets allows you to make arrangements of widgets in very flexible way, but also because widgets are objects, you can actually pass them or return them from functions. So one of my recipes, let's say, is if I need certain layouts of widgets to be made dependable on options that the user has, then what I have is that I hide the construction behind a function that takes parameters. I create within the function all the widgets that I need to make on the order that I need them to be according to the input parameters. And then I return basically the parent object, the parent layout object, and then I can use that in any other way. So it's a way of abstracting a lot of code, and so it makes it very clean. And finally, the dashboards is like the cherry on top that allows me to have everything very flexible on the screen. And very honestly, I will tell you that this is it on the theoretical part. With these elements, I think you can fit a train sideways, and you can do much of the things that you want, as long as they are prototypes, I will say. So let me give you a toy example. I'm a network engineer. I love my networks. It's going to be a bit misleading. So networking is a big field. But here I'm going to talk a bit of how, a toy example of trying to explore the internet traffic of a big ISP, a big internet service provider. Because I have to talk about networks, then I'm going to give an introduction of how the internet works, just for the sake of it. So I don't know if you know how the internet works. So basically, the internet is this arrangement of networks. We have around 55K of them. They are called autonomous system, actually. That's a technical term. You and me, we are not networks of this. We're not networks on the internet. We're just users of a single network. Universities like this, sometimes they're not networks. I mean, sometimes they actually behave like us. They're just clients behind a single network. So for you to be a network, you need to go get a number, a bit of governance, a bit of politics, and then you can join. And if you want to connect to the internet, you actually have to connect to other networks and make arrangements with them. And this is the most capitalistic process in the world. I mean, there's nothing. I mean, the internet works pure business. There's nothing social. No, everything is business in the internet. So if I need connectivity, then one way that I can go is I can go to another network and tell them, okay, I pay you and you give me transit, and so you pay them money, and then you become, let's say, customers of them, and they basically follow they give you the traffic that they have for you, and they deal with the traffic that you send them. That's a way of connectivity. The other typical one is called serial-free peering, and basically is when I know in my traffic, when I see, this is the topic of this toy example, when I see that I have a lot of traffic to another network and I'm not connected directly to them, I can go to them and tell them, look, Carlos, so we have a lot of traffic with each other, let's connect. And Carlos says, okay. And so you arrange maybe where you have to put the cable. Remember, everything are cables. You don't want wireless here. So you connect the cable somewhere. You have to see which building, and that's it. And then, okay, then you have a connection. The internet 10 years ago was dominated by the customer transit type of links. So it was very pyramidal, so something like this. Now it's more dominated by the peering links. So it's more flat. There's just PhDs about that if you want to check it. Okay, so let's say we have a connection already, so we have a link. And the question is, okay, how can I tell you which networks you can reach through me? So that's why we use the BGP protocol, which is the core of the internet, let's say. So you basically tell the other networks what you can reach through you, and you receive receive the networks that you can reach if you send them the traffic. As with most routing protocols, you have to know that routing protocols usually, because that leads to instability, do not lead with congestion. So they don't have congestion of the links or capacity on their algorithms. So it's up to the operator, let's say, to be able to move the traffic and in such a way that the links are healthy. They're not that they have, that they are not congested. This is typically called traffic engineering. Okay, all of this will be kind of important for the actual example. So what we have, let's say, what we have is a fictitious data set that I built, let's say educated fictitious data set that I built for a fake transit provider that is connected to 6 different networks. Let's hope this works. Well, it's not that pretty, but it more or less has. But I really want to show this address. So what we have is we have a big data frame. It has, so for every let's say row, we have a destination and a source net. I hope you can see it. So that's an IP version 6 address. I hope you recognize them. If you don't, and if you ever have to write code to deal with IP addresses, please make sure that your code deals with both the typical IP version 4 ones and the IP version 6 ones. Python has this IP address library made for Google. In Python 3 is there. So try to use it. It's a bit slow, but it will deal with it. It will deal with it for you. It will deal with the networks for you. Okay, so this thing doesn't go that way. Well, okay. So there's a source destination router, source destination IS, egress and ingress link. That actually, getting this information is the hard part. And that's actually my job, to try to get that information and to put it in this nice way. But I did the hard work for you. Okay, so let's see what is the use case. What do we have to do with this data? So let's just try to provide an operator with a way of exploring it so they can make decisions, such as the one that I just said before, which networks should I peer with or stuff like this. And second of all, let's try to be fancy, and let's try at least to provide some functions of load balancing. So let's try to provide a way to tell the operator, look, exchange the traffic like this so you can have better balance in the network. The workflow that I will propose for this, I tend to like to have I like the divide and group approach, which is basically when you have a data set with a lot of features, a lot of characteristics, and you need to explore it. I like to first provide users with a filtering approach so that they know exactly what they want, so that they say, hey, this is what I want to explore first. And then I like to give options of grouping on the different characteristics so they see what's going on. So this is what we're going to do here. So first I'm going to offer in widgets a way for operators to filter what kind of traffic they want to actually see. And second, I'm going to divide that traffic into 3 sites for a reason. The first site, I'm going to let them explore the whole thing that they filter. Second, I'm just going to focus on the ingress traffic. Then I'm going to focus on the egress traffic so that they can explore those 2. And more importantly, I'm going to focus on ingress and egress because the load balancing depends. So the load balancing is specific for egress or for ingress. So I'm going to do that. Before, let's say that because the traffic is basically a time series, then it makes sense to have a, let's say, kind of a widget. It's not really a widget. It's an arrangement of widgets that lets you explore this time series. What this widget will do, well, this is kind of by experience. When you have a time series, I usually like to explore it first by looking at the behavior in time using a figure. But I also like to see like numbers using a table, ignoring the time, so basically having the mean or the sum. Because with the numbers, I get some information from the numbers, and from the figure, I get the behavior in time. I also don't like to see thousands of flows or thousands of time series on my figures, because that basically doesn't give you anything. But I know that if you selected your data well, you usually follow the rule of 90-10. That means usually 10% of the flows, they have 90% of the traffic, at least on the internet. And so basically, I'm going to show not everything, but I'm going to show just the top contributors. So I did this already. So what I did was, and the code is in the GitHub, but what I did was basically create this figure, this function that, given a specific data frame, I basically tell it which is in the data frame, which column is the time, but it's the time on that time series, which column is the value of the time series. Then it takes that all the rest are characteristics of the time series. And I also tell it if I want a widget that is vertically aligned or horizontally aligned. What it does is, well, unfortunately it doesn't see so well, but you have here all the attributes in which you want to group, and a button to update. I don't like to do automatic stuff. I actually like to buttons, because if not, then the whole notebook might get crazy. So for instance, if I wanted to see just the egress link division of the traffic, then what happens is when I update the button, the figure gets refreshed. So this is what I told you, that I like to see the numbers on a table, and I like to see the behavior in time with a graph. But this conveys me some information, this conveys me another. And this is a function, so I can actually give it as many data frames as I want, and they will be, and this thing will be created, and it returns a widget, so I can put this widget in other widgets. And that's it. So let me tell you at the end what I did based on this workflow, how I, unfortunately it doesn't look so good, but so basically here on this box here, oh, let me go to the actual preview. So in the box here, we are basically allowing the operator to select which traffic they want to see. So maybe they want to see only the traffic for a specific autonomous system, so specific neighbors, or they want to see the traffic on a specific routers. So let us just see, I don't know, this one. So when I press this button, it takes the big data frame, it filters just for the traffic of that IS, and it repopulates this with the resulting data frames. Here I can explore the whole traffic, and the beauty here is that here I can explore, I remove basically, well, I group over the egress links only, so I can focus on that. And if I see here, this neighboring IS has 3 different links, one in Frankfurt, one in Amsterdam, one in Barcelona. And the traffic in Amsterdam is a bit bigger. And if you see, the difference in traffic are big. And happens that if the operator decides, because of their policy, that it is the same for them to send traffic in Frankfurt, Barcelona, or Amsterdam, then what you can do is that you can try to move traffic across the links, because, I mean, it's the same destination. So this was the second use case of this toy example. So here I have another widget which basically incorporates this load balancing algorithm that I did. It works perfectly because it's a toy example, but the idea is the same. So basically, from this input, this thing that it thinks moves, it's a prototype, nobody cares. But if in a real dashboard, they will drive people crazy. So here are the 3 links. This is the resulting, and it actually tells you how you will get the thing on the right. So it tells the operator, okay, so if you want this, you have to change. You have to change the traffic of this network to the link in Amsterdam, because obviously the link in Amsterdam is lower. And then you can do a lot of these small changes, and you get the thing on the right. To do this algorithm, I basically ignore time, because doing load balancing with the time dimension is a pain. It's even hard to define. So I just ignore time. I just take the sums of all the characteristics on the period, and then I do kind of a heuristic to move. I move elements until I minimize the standard deviation of the whole thing. Okay, I could do the same with the ingress. Actually, the ingress will look, well, I'm not going to do it, but just to see how it looks. Okay, it looks different. I could also try to do the load balancing. As a bonus, I couldn't finish, but as a bonus, I also wanted to try to show you how an operator could work with router configuration. Router configuration is like the holy grail right now of networking, because you see there are a lot of vendors, including my employer, and all of them, they have their own ways of configuring the routers. And right now, as an industry, we're trying to move to, let's say, common models. And these common models are very nice. They're in JSON, or well, you can get the configuration in JSON, a standard way. So to do this, I actually try to do like kind of a JSON navigator that will get the JSON configuration of the routers and allow the operator to go over the JSON. I kind of thought of this Mac, when the Mac goes into the files, it has this kind of, in which you can go hierarchies of folders using Windows, so I wanted to reproduce that. So okay, doesn't work so well yet, but this is all done by widgets, and I think it's kind of fancy, although not super, but you can do that with widgets. So message, widgets, if you spend enough time, you can do kind of nice stuff. Okay, so that is actually most of it. I just have a final conclusion that my final conclusion is, at least if we are doing prototypes, the perfect is the enemy of the getting things done. So these libraries, and I'm pretty sure Boketu and other libraries that are, say, traps, hooks into JavaScript, they probably will drive you crazy if you want to get everything right. I still don't know how to make the bottom font bigger. I can make a button the size of the screen. I don't know how to make the bottom font bigger. I don't know if it's feasible. I haven't seen it in Stack Overflow, so I don't know. I haven't done it. And I don't know if you can do it. So, and that will be a pain if it's an end product, but for a prototype, it's perfectly fine. So I will tell you, if you're doing prototyping, just spend enough time that you convey your message, but do not exaggerate, because it's not that good for your health. Okay, so just two things to finish. Well, I wanted to talk a bit more about networking, but I needed to talk about Python actually. So if you guys are in Barcelona, we have an SDN meetup. So we have a networking meetup. It's called Software Defined Networking Meetup. We're not that many. If you are interested in networking, please come. We'll be happy to have you. Yeah, that's on one side. The second side is that if you actually want to, so this is a toy example. If you actually want to explore time series, there are these products called, well, these projects called Kibana and Grafana. They're really nice. Use them. Do not use, well, don't reinvent the wheel. I mean, they are very good. For the exploration side, although if you actually wanted to do that router configuration or that load balancing easy widget, you will struggle because everything is in JavaScript and things. So yeah, that's it actually.
Thanks, Juan Camilo, for this amazing presentation. So, any questions?
Thank you. Is there any way to share the dashboard with users that don't have Anaconda installed?
What?
So you developed the dashboard.
Yes.
And is there any way to share it with people inside of organizations that don't have Anaconda installed or Jupyter?
I don't know if it works with. Well, there was a talk about Jupyter in the cloud. Maybe I don't know if it supports extensions, because you will need the dashboard extension if you want this. That is the solution that comes in top of my head. But usually on these prototypes, well, what I think is that you go into meetings and then you can show with your computer in a more relaxed way, or you share your screen. So, but yeah, well, if this, I think I should have gone to that talk, but maybe that is the solution that probably could work well.
Okay, thanks.
More questions?
Hello, thanks for the presentation. Actually, it's not a comment; it's a question. It's a comment. Actually, there is a tool to share your local projects through a secure way in internet. We can talk afterwards if you want. And there's a project. It's called NORC, and it's typically used for that. I mean, to share some local project to someone through the internet in a secure way.
More questions? I have one question. When you are dealing with this data is already on memory, or you can connect to databases in a synchronous way, for example?
Well, no, this one is in memory. To connect, to have something like a streaming or something like that, we will need something, yeah, more fancy. But as long as it's in a data frame in memory, you can work it out. You will have to figure out the other part of the. So actually, in one of my projects, I do have some PySpark doing something, and then having some remote calls to get the data and update the widgets. But I do update it with a button. It's not like fancy things moving without you. I tend to like more triggers in prototypes than things that move on their own.
But it could be done with the widget.
Well, I did something. Yes. Yeah.
More questions? No? Then let's thank Juan Camilo again.